Dear students, today we are discussing about some scale of measurements. Okay, sometimes we may have to measure the observations. Okay, for example, suppose we are conducting a survey, so we can ask questions like this: do you have access to computers? The possible answer will be yes or no. Okay, so that is a data. Another question is, do you have access to internet? So the possible answer is yes or no. Okay, so there is no preference among these options, yes and no. And you can see in the question number 5, please name the banks you are regularly dealing with. So we can take any one of these name of banks. Okay, and another possible question is, what type of accounts do we have? Savings account, current account, current deposit, fixed deposit, etc. How many accounts? So we have to collect the information based on some questions. Okay, so this type of yes or no type questions are just response only. Okay, there is no what is that? It is usually called categorical data. At the same time, there is no preference. For another example is male or female. Okay, there is no preference. If male, we can denote it as 1, and if female, we can denote 0, okay, or 2. So that type of categorical variables are usually called nominal variables. So nominal data are numerical names only. Okay, nominal data is numerical names only, because they do not share any properties of the numbers we deal in ordinary arithmetic. We know that in in mathematics we can say that 2 is bigger than 1. At the same time, in the case of this type of yes or no questions, yes is not bigger than no, or no is not bigger than yes. So that just representation only. Okay, so that type of data are called nominal data. Now, what will be the ordinal data? So another type of data is ordinal data. Okay, if there is some ordering, like the age of a person, for example, it may be 12, 18, 25, etc. So there is an ordering. Okay, so we have to consider the magnitude also. Okay, so that type of questions are called data are called ordinal data. Okay, that means there is a preference, should be some less than or greater than behavior will be there, may be increasing or decreasing. Okay, the values may be increasing or decreasing. So another example, mark is a ordinal data. Okay, mark as an ordering. If mark is 25, that is less than 50, so mark will be an ordinal data. Example. Another type of data is interval data. Okay, you can see that the temperature lies between 0 and 100. Okay, how many students are having mark in between 60 and 80? Okay, so it may be some 5 or 10, etc. So that type of data are called interval data. Okay, when in addition to setting of inequalities, we can also form differences. We refer to that data as interval data. Okay, for example, degree Celsius, that means 58 degrees, 63 degrees, 70 degrees, etc. So that is usually called usually we can consider it as a interval data. Okay, that means we can also form differences. It is importance. Maybe usually it is continuous data. Okay, interval data is also called continuous data. Temperature, or what is the mark, height, weight, etc. or all are interval data. Okay. Another is ratio data. Okay, for example, consider length, height, money amounts, weight, volume, area, pressure, etc. because in addition to inequalities as in the interval data, and we can also form quotients means we can we can operate mathematical operations on that data, like multiplication, addition, subtraction, quotient, division, etc. So there are that type of data are called ratio data. Okay. Ratio data. Examples includes length, height, money amounts, weight, volume, etc. So sometimes we have to select the data in any one of this category, any one of these four category. First one is nominal data. There is no preference, just numbers. Interval data, ordinal data, there is some inequality, equality or preference. And then interval data, we can take the difference of that data. That will be meaningful. That difference will be meaningful. Then ratio data, we can take the quotient also. So that type of data are called ratio data. And these four categories, when we take a observation, that observation will come in any one of this category. Okay. So nominal scale is simply a system of assigning number symbol to events in the order to label them. For example, male, female. Just that scale is called nominal scale. Nominal scale. Just we are assigning the number male, female, 1 for male and 2 for female. And that is an example nominal scale. Then another is ordinal scale. Ordinal scale, the lowest level of ordered scale that is commonly used is the ordinal scale. The ordinal scale places events in order, but there is no attempt to make the intervals of the scale equal in terms of some rule. Okay. Should have some order. Okay. Another example is, what is that? Age is an ordinal variable, and I will show you in the questionnaire. The last you can see there are plenty of questions available. Here it is, sex is given. This is a nominal scale. Age is given, so there is an order preference, so that is ordinal scale. Education, it is also ordinal scale because it has some order. SSLC is lower than pre-degree, that is lower than degree, lower than PG, etc. So there is an order. We can assign 1, 2, 3, 4, etc. number for this. Occupation, we can order. Marital status, that we cannot order, that will be nominal scale. This annual income, that will be an ordinal scale. We can take any one of this and code the number as 1, 2, 3, 4, 5, etc. So that are called ordinal scales. Okay. The ordinal scale places events in order, but there is no attempt to make the intervals on the scale equal in terms of some rule. Rank orders represent ordinal scales and are frequently used in research relating to qualitative phenomena. Okay. Oh, okay. Let us consider what is qualitative and quantitative data. You know, qualitative data. Quantitative data can be counted. For example, mark, then height, weight, income, etc. That are quantitative data. Quantitative data can be counted, measured, and expressed using numbers. So, what is qualitative data? Qualitative data is descriptive and conceptual. For example, beauty. How can we measure beauty? Beauty will be, we can order, rank, highest beauty, second highest beauty, or intelligence. We cannot measure. How can we measure the intelligence? We cannot measure. So we can order a person is more intelligent, then we can rank him 1. And if another person is having some lesser intelligence than the first person, we can rank 2. So that type of data are qualitative data. Okay, this conceptual. Qualitative can be categorized based on the traits and characteristics. So we can categorize what is that? More intelligence, average intelligence, less intelligence, less beauty, less average beauty, highest beauty, etc. So that type of variables are called qualitative variables, and the data are called qualitative data. So another example of qualitative data are text of documents, audio, video recordings, images and symbols, interview transcripts and focus groups, observations and notes, etc. So we cannot assign a number, but at the same time we can collect the data. In big data analytics big data analytics is an emerging field during these years. Data science, a new generation course working in our college, and moreover this course is available in different University of India and abroad. The American universities like Stanford University, Harvard University, etc. They have started MS course in data science jointly with the computer science department. So what is the need of that course? So, one of the application of that course is we have plenty of data available in the internet. Okay, when we text a message in WhatsApp, when we send a photo in Facebook or WhatsApp or through any social media, that is a data. Based on that data, we can take decisions according to that. But how can we measure that data? That is impossible. So that type of data are called photos, text, audio, etc. are called qualitative data. So so we can use an ordinal scale for measuring the quality data. Rank orders represent ordinal scales and are frequently used in research relating to qualitative phenomena. Okay. A student's rank in his graduation class involves the use of an ordinal scale. One has to be very careful in making statement about scores about the ordinal scale. For instance, if Ram's position in his class is 10 and Mohan's position is 40, it cannot be said that Ram's position is 4 times as good as Mohan. The statement would make no sense at all. So we should care about when we interpret the ordinal scale values. So we can assign numbers, but that should be meaningful. Okay. Thus, an ordinal scale implies the statement of greater than or less than. Equally statement is not applicable. So we can rank like first rank, second rank, etc. Another is interval scale. Okay. In the case of interval scale, the intervals are adjusted in terms of some rule that has been established as basis of making the units interval. For example, we can consider the temperature. Okay, how can we measure the temperature? We can measure temperature from 0 to infinity. Okay, we can measure the temperature 0 to infinity. So that numbers, for example, 30 degree, 40 degree, 30 degree to 40 degree, that shows an increase. Okay, that shows a continuous increase. From 60 degree to 70 degree, we can consider the increase. Okay, so that's only a what is that? These are called scale variables. Okay. Interval scale. Interval scale provide more meaningful measurement than ordinal scale. For interval scale also incorporate the concept of equality of interval. So we can apply several statistical tests in the interval scale. If the observations are like this, Another example is mark of statistics or mark of mathematics. That is also an interval data. That is a continuous data. Okay. Now we consider ratio scale. Ratio scale have an absolute or true zero for the measurement. The term absolute zero is not as precise as it was once believed to be. You might have heard about absolute zero in physics. That is not that absolute is not considered here. For example, length zero means, what is length zero? Length zero means there is no length. Okay, so from the measurements are from zero. Okay, the measurement, but the temperature is not from zero. At the same time, in the ratio scale we should have the measurement from the reference point is zero. From the length, we are taking the length or height or velocity, everything is, there is no negative value. Okay, we are taking the observations based, with the reference to zero. Okay, but at the same time in the interval scale we have zero. For example, negative will be there, negative temperature is there. Example is temperature 0, but there is no negative distance. So in the ratio scale we should not have negative values. The reference value is 0. So these are basic informations about the scale of motion. I will show the example. Consider this we can represent strongly agree, no opinion, disagree, strongly. So there is an ordering here. Okay, either increasing or decreasing. So we can order according to its degree of agreement. So this can be represented as 5, this can be represented as 4, this 3, 2, 2, then 1. Okay, so that number itself represents some degree of agreement. That number shows some degree of agreement. Or otherwise we can represent, like if we consider this variable can be considered as interval scale, we can consider the values 2, 1, 0, -1, -2. That number shows the degree of or the agreement, the rate of agreement. At the same time it can be represented by negative numbers also. So this variable can be considered as interval scale. Okay, but at the same time if you refer length or mark or height or weight etc., we should have considered it as a ratio scale. These are all interval scale. Okay, these are just categorical variables. There is no preference, always, frequently, occasionally, rarely, never. These are only nominal variables. These are also nominal variables. Highly satisfied, no opinion. We can assign 5, 4, 3, 2, 1 or 2, 1, 0, -1, -2, because we can consider it as an interval scale. Okay, so these are examples, and I think mark is given. This is a rank. Okay, we are giving the rank, mark. Give the mark in order of importance. Distribute 100 as okay, so we can mark, give the mark to the variables, and that will give a preference. So these variables can be considered as, what is that, ordinal scale. Okay, there is a preference, ordinal scale. This is only just nominal scale, just to tick only, just to select the category only. There is no preference. Okay. So I think you got the idea. And once again, let me come to the qualitative, quantitative. What is quantitative data? You know, uh, uh, qualitative data. Quantitative is a statistical and typically structured in nature. Because when we take the mark of a student, so that gives a quantity. Okay, that represents the size of that data. Also, that quantity represents the degree of his what is that, awareness. Okay, so that type of data are called quantitative data. How can we take the quantitative data? We can conduct the experiments. For example, we can conduct a physics experiment and record the observations. We can conduct surveys using this type of questionnaires. You can have the answer and it will be some numbers for all the answers. We can put number here, or if we tick here, we can give the number 1 or 2 or 3, 4, 5, etc. So we will get some data, numerical data from the quantitative variables, marker reports, matrices, etc. Continuous data. Okay, you can refer the this book. I have shown you the book of Kothari. I think I have shared with you. If it is not available with you, I will share, and you can take the note from using that book. Okay, because this is a research book. This research book is fully devoted to the statistical tools for doing statistical analysis. So each and every informations are provided in this book for conducting a research, like qualitative data, quantitative data, scales, variables, and analysis steps. Everything you can see. So you can refer this book. This is a good book. I will share it with you, and you can use that also. Okay. What is time series data? You know what is time series analysis? Time series data means the data. I will show you some time series data. You can understand the concept. Time series data is data collected in time. Okay. For example, market price. It's a time series data. Otherwise, you can see several reports in Reserve Bank as well as government departments. In all these government department Reserve Bank reports, you can see plenty of data. Okay, I will show that data. So this type of data we have to analyze in reality. So you must study the importance of this type of data. So this is a report of Reserve Bank of India regarding GDP, GDP growth. So this is a time series data, 2011, 2012 data, and in every point you can see data, and there is a plot associated with this data, and this plot is called time series plot. So these are called data obtained according to time are called time series data. This is another time series data. In every year you can see in between every year you can see some data, and in that data they have plot one continuous diagram. This is another. So you can see the importance of this histogram and this this type of graphs. These are all statistical graphs. We have studied all these techniques in this semester. you have to study in detail. We got only a little time to discuss all these things, but you have to refer this type of reports and get motivation to study the topics in the syllabus. Okay, so these are time series data associated with some sales growth. Okay, hundreds of data we can see, and sometimes you may be employed in future in these institutions, Reserve Bank, NSSO, CSO, or any government departments. Then you may have to use this type of statistical tools for making the reports. So at that time you have to understand the concept from the beginning itself. Okay, so many time series data you can see, and you can use this type of time series data in your research. Okay. Okay. Anyway, I think we have discussed the diagrams like frequency diagram, polygon, etc., cumulative frequency function. And in the next class we will discuss box plot, importance of moments, central moments, non-central moments, their interrelationship, measure skewness based on quartiles, measurements, etc. That will be discussed in the next week. So before that, you can study these topics. I have mentioned only some main points only. You can read and make at least 3 times you can read this chapter. Discussed contents. At least 3 times you read and make a proper report. Okay. You can submit in my Moodle platform. Thank you.